Hey everyone, so in this video I will show you how to perform binary search in Python. But first let me actually explain to you what binary search is and how it works. So binary search is basically an algorithm that takes an ordered set of data and it finds a specific value in that data using kind of a divide and conquer method. So here I have an array of numbers, each with their index value listed down here below. So how binary search would work is, let's say I want to find 35. Okay, that's the number that I'm searching for in this dataset. Okay, what it will do is it will take the leftmost index and the rightmost index, so 0 and 6, and it will add them together. Now 0 plus 6 is just equal to 6. And what it will do with this is it will floor divide by 0. So what floor divide does is if we get a decimal number, it will just truncate that and give us the whole number value. So if we floor divide 6 by 2, we're going to get 3. And so now this 3 is what we call the midpoint index, because it goes to index 3 and assigns the value 6 as being the midpoint. Now, in this case, the number we're looking for is 35, so I'll put it down here. That is our end goal. Now what the algorithm asks itself is 6 greater than 35? Now in this case, we know that that's not true because 35 is greater than 6. And so the algorithm automatically knows that everything on this side is useless to us, because since 35 is greater than 6, it cannot be any of these numbers as all of these are less. So it basically gets rid of all of this data here, and because it doesn't need that. And it now just looks at these 3 pieces of data. Now it does the same thing now because it looks at the leftmost index and the rightmost index, 4 and 6 in our case. Now 4 plus 6 equal to 10. Now if 4 divides it by 2, so divided by 2 is equal to 5. And so now on the second running of this, 5 is our midpoint value. Now it checks, is 35 greater than 35? Well, in this case, it's the same, right? So the algorithm would know that because it won't only be greater than, it will be greater than or equal to. And so since 35 is equal to 35, we have found our value and the algorithm ends. Now, using this method, it can basically find any of these values. So now let's actually code this out in Python. First, I made a list so we can actually test our binary search algorithm. You can feel free to make any length and any sort of list that you want, but I will be using this one to actually demonstrate the algorithm. So now let's make a function called binary search, which will take in list and num. Now I will say start index equal to 0, end index is equal to len list minus 1. So it's just saying that the start index will be 0, so the first value, the end index will be the last value. While true, we can say that the midpoint, which is the midpoint index, is equal to start index minus end index. And I'm going to put this in brackets. Floor divide by 2. Just a reminder that if you want a floor divide, you should have 2 slashes and not 1. Now if list midpoint is equal to the number that we're looking for, we can say print, and I will make it a f string, the number was found on index midpoint. Actually, to make it better, I will just get rid of this and say num was found on whatever index it was found on. And of course, we will break it out of the while loop. Now we can say if list midpoint is greater than num, well, then what we would do is we would take the end index and we would make it midpoint minus 1. What we did here is if the number that we're looking for is less than the midpoint index, well, then we'll make the end index 1 less than the midpoint, so we only have to look at the necessary values. And same thing almost if the midpoint index is less than the number, meaning the number is greater than the midpoint index, well, then we can manipulate our start index into being midpoint plus 1. And that's about it. So down here, so now let's actually run this algorithm on this list over here, and I will first number I'll just choose 6. I'll say 6. Now if we run this, it says 6 was found on index 3. That's true, because it starts at index 0, so 0, 1, 2, 3. So we know this works.